Hello everyone. In this lecture, we will be talking about data cleaning and preparation techniques when we are working with data frames. This is chapter 7 of our second textbook, Python for Data Science and Analysis. Learning objectives include tools and methods for handling missing data, duplicate data, and some analytical data transformations. One of the benefits of Pandas library is to work with missing data easily. For instance, all of the descriptive statistics on Pandas object exclude missing data by default. So there are different ways to handle missing data. We can drop them or we can replace them with some values. So we are going to talk about each strategy. For numerical data, Pandas uses the floating point value NaN or not a number to represent missing data. Here you can see an example. First, we are importing numerical Python library. This library has a large collection of mathematical functions. So from this library, we import NaN, which represent not a number points, and then we assign capital NA, which represent missing values. So we are going to talk about numerical Python library later on, but for now we import the not a number entity in order to represent missing values. Now we create a data frame. So we use pandas pd.dataframe, and here you can see I'm using a list of lists. So this data frame has 3 columns and 4 rows because we have 4 lists here, and some of them have missing values, as you can see NAs here. Now if we want to clean the data, we can drop all missing values and we can use drop NA method. So we call the data.dropNA, and this method is going to drop all rows and columns with at least 1 missing data. Now, if we pass how equal all, then it only drops rows that are all NA. So, for example, here the third row, which has all not a number values. And if we want to drop columns in the same way, then we pass axis equal to 1. So let's try run this in a notebook so you can see what the results look like. First, we are going to import not a number from numerical Python package. And then I am assigning a nickname and a. Then we can define our data frame. So we call pandas.dataframe. And then we have list of lists. So you see a square brackets. The first row we have 1, 6.5 and 3, comma, the second row another list 1 with 2 missing values, so 2 NAs. For the third row we have a row of missing values, and the last row we have 1 missing value and 2 numbers, let's say 6.5 and 3. Let's run this, and then we can print this data frame. So you can see we have 3 columns and 4 rows, and then missing values have a special value NaN, which represent not a value. Now if we apply drop NA, so we call it the clean data. So data dot drop NA. Let's print the clean version, and you can see that this data frame only has one row, which is 0. So drop NA is going to drop all rows and columns with at least one missing value. Now let's pass access or how argument. So data dot drop NA how equal to all. So this one drop rows that that has all missing values. So let me add a comment here, drop rows with all missing values. So we only have one row in the original data. So you can see that it drops the third row because it has all numerical missing values, and it keeps the other rows. Now if we pass access, then it applies to columns. So data dot drop NA, but this time we pass access equal to 1. So this one drops columns the same way. Let's apply this. So you can see that all columns have at least one missing data, one missing value. So when you apply access 1, then it's going to drop all observations. So your data frame is technically empty. So dropping missing values is not always the best strategy. It depends on the size of data set and how you want to handle data missing values. The better way is to fill in missing values. So rather than filtering out missing data, just like what we did, you may want to fill in the holes in any number of ways. So there are different ways. There are some statistical techniques that you can fill in missing values. For most purposes, the fill NA method is useful. So when you call fill NA method, then you can replace all missing values with a number. In this example, let's say we want to replace them with 0. You can also pass a dictionary. Calling fill NA method with a dictionary, you can use a different fill values for each column. For example, for the first column, or variable, you want to replace missing values with 0.7, as you can see in this example. For the second column, you replace missing values with 0.5, and for the third column, you replace them with 0. So let's run this. So data dot fill NA with 0. Now you can see all missing values are NaN, special values are replaced with 0. You can replace them with 1 and then we run it, then you can see 1. Or we can use a dictionary to assign different values. So data dot fill NA, and then you define a dictionary. So for the first column, we assign 0.7. For the second column, we assign 0.5. And for the last column, we assign 0. So if you run this, then you can see the missing values for the first column are replaced with 0.7, 0.5, and then 0 for the last column. So far we discussed two techniques. We either filter them out or we fill in with some numbers. So with the fill NA method, we can do lots of other things with a little creativity, and that's where a statistical techniques can be useful. For instance, we can pass the mean or median values of a column. So we find the mean value or the median value and then replace the missing values with the mean or median. So I usually prefer median value because it's more robust. In other techniques, you may fit a linear regression and then predict the value for missing data points. So there are different techniques, but with this function, fill NA, you can do or handle missing data based on different functions. So in this example, data.fill_NA, I'm replacing all missing value with the mean. So for each column, I calculate the mean value, then we assign that value to missing data points. The same for other columns. In the next line, you can see the same structure, but this time we are passing a median function to the fill_NA method. So let's implement this in a notebook and you can see. So I call data. Again, we are using the same method, fill_NA, but for the first column, so in order to get access to values, the first column, we call data 0 because the first column name or header is 0. Then apply the mean function. For the next column 1, so we update data, then the column, here is data 1, then find the mean value, which exclude all missing values to calculate the average, and then assign it to missing data points. And then the last column, data 2, apply the mean function, and then assign it to missing values. So if we run this, then you can see the mean here. This is the original data. The mean for the first column is 1, the mean for the second column is 6.5, the mean for the third column is 3. And now what you see here. So technically, all data points would be the same. So if you apply median function, you will see the same result because this data frame is the simple one. So that's how we can handle some missing values in your data. But you can also search for duplicates. So duplicate rows may be found in a data frame for any number of reasons. For example, user errors. So there is a method to identify duplicate rows. So data frame method duplicated returns a Boolean series indicating whether each row is a duplicate or not. Here I'm creating a data frame with 2 columns, K1 and K2. So K1, I'm using the list 1 and 2 times 3. It means that repeat this list 3 times. At the end, add the value of this list, which is 2. And then the second column, we are assigning some numbers. Okay. Then we print the data frame, and then we apply duplicated method. So for each row, we see the Boolean statement. If it is a duplicate row, then we see true or false. So you will run this, and you will see the result. There is another method, drop underline duplicates. If we want to drop the duplicated row, then we apply this method and it returns a data frame where the duplicated row is dropped. So drop underline duplicates. So let's create this data frame and then we apply the duplicated method to see the true false result, and then we drop the duplicated row. So data equal to a new data frame with 2 columns. I'm using dictionaries. So the first column, K1, I'm using list to assign values 1 and 2 times 3. So it repeats this value 3 times, and then we assign 2, or we add 2 at the end. Next column, K2, and then the values are, let's say 1, 1, 2, 3, 3, 4, and 4. Okay, we run this and let's print this data frame. Okay. So you can see that we have 2 columns, and 1, 2 is repeated 3 times, and 2 is added to the end. So we have 7 rows, and you can see that the last row is a duplicate. Now let's apply the duplicated method and see the Boolean result. So data dot duplicated. So the first one, it's not a duplicate, so it's false, false, but the last row is a duplicate and the Boolean value is true. Now, if you want to drop the duplicated rows, then we apply drop underline duplicates. So data dot drop underline duplicates, and then you can see that it drops the last row. So that's how you can check for duplicated entries. Another useful technique is transforming data using a function or mapping. For many data sets, you may want to perform some transformation based on the values in a data frame. You can define a function, or simply you want to standardize the data. So in this case, we can use the map function. So using map as a convenient way to perform element-wise transformation. So it will be applied to all elements of each row or column. And this is map method is a useful technique for data cleaning related operations. So here you can see an example. First, we create a data frame using the dictionary with some missing values. First, we fill in missing values with median, and then we apply this function lambda. We have seen this before when we were discussing apply and lambda method. So we define the function lambda x, and let's say we want to multiply all items by 2 in the first column. So let's create this data frame, print it, and fill in missing values, and then apply the function to the first column. So data is equal to pd.data frame. Again, we have a list of lists. 1, 6.53 for the first row, second row, 4.5, NA and NA, which represent 2 missing values, and the second row. And then we have 1 missing value, 10, and another missing value in the third row. And in the last row, we have 1 missing value, 8, and 4.5. Let's print this data frame. So you can see it has 3 columns with 4 rows and some missing values. Then we want to fill in the missing value with the median. So I assign this to a new data frame. So I define data2, data, apply, fill, NA. Then I use a dictionary because I want to assign different values to each column. The first column, data 0, calculate median. next column 1, data 1, and calculate the median value and assign it to missing values. Then the last column, data 2, and now we run this, and if we print this data frame, then we don't see any missing value, and they are replaced with the median of each column or variable. And now we want to apply a function to all elements or all data points in column 0. So data to first column, then we apply the map method or function. Lambda is a reserved word, so it's green. X, and let's say we want to multiply all items by 2. Then if you run this, then you can see 1 times 2 is 2, 4.5 times 2 is 9, and 2.75 times 2 is 5.5. And that's how we can update the values for each column based on the function that we define. So we use this map function for data cleaning operations. Now, there is another method called replace that we can replace values in a data frame. Map methods can be used to modify a subset of values, for example, the first column or the third column. But replace method provides a simpler and more flexible way to do so. So there is a method called replace. So we call the data.replace. And then we want to replace, in this example, 6.5 with 6500. So it's going to find 6.5 in the data frame, no matter it is in the first column, third column, and then replace that with 6500. And another example, we replace 3.75 with NA, a missing value. Or we can use list. So we'll replace 1 and 2.5 with 10 and 27. So let's apply this to the data that we just created. So data 2, this is the original data 2. Then you have to see the table. Then we apply the replace method. Now replace 6.5. So there is one 6.5 under column 1 and row 0. If we run this, then you see, okay, this 6.5 is replaced with 6500. Or we can replace 3.75 and we have 2 data points under column 2. And we want to replace them with missing values, a special not a value. And then you can see the result. Or in another example, it's applied to data. Let me apply this to data 2. Okay. Now you can see in data 2 we only have 2 3.75. Now they are replaced with a special NaN value representing missing values. Now data 2 replace. Now we can use list to replace several values at the same time. So 1 and 2.75, and we replace them with 10 and 27. So you can see 1 is replaced with 10, and then 2.75 are replaced with 27. So that's how you can manipulate data frames. So far we went over some useful methods to update values in rows or columns. So another type of transformation that we use a lot for a statistical modeling or machine learning application is converting a categorical variable into a dummy or indicated matrix. This is really important because we shouldn't treat categorical variables like ordinal variables. So for instance, if a column in a data frame has k distinct values or categories, you would drive a matrix or data frame with k columns containing all ones and zeros, and that's why we call them dummy variables or indicators. In this example, we are creating a data frame which has two columns, keys. Under keys, you can see we have A, B, and C, three main categories. And then the second column, we are using the range function to generate some numbers. The method that we use to transform a categorical variable into a dummy variable is get underlying dummies. So we call pandas library, then we apply get underlying dummies, and then we specify the column, here keys. And sometimes you prefer to add prefix to the column, and then you can pass prefix equal to key, and then you are going to see key underline the column name. So let me implement this in a notebook, then you can see what the results look like. So we are creating a data frame, and the first column has three main categories. So pd dot data frame using a dictionary, keys, the first column, and then we have a list. Let's say B, and then A, C, and A and B again. The second column, call it data 1, and then we use the range function to generate some numbers. If we run this and then we print this data frame, so you can see that we have 6 rows because we used range 6. We have 2 columns, keys and data. So keys column has 3 main categories, A, B, and C. And now if we apply the get dummies method, then we are going to see the indicators or dummy variables with all 1 or zeros. So I call pandas library and then get underline dummies. Then we call the data frame and the column, this example keys, and when you run it, then you see 3 columns because we had 3 categories, right? A, B, and C. And then for each column, you see only zeros and ones. So look at the first column, A. So in the original data, the third observation and the fifth observations, the sixth observation has A. So here you can see the third and the fifth observation's value is 1, the rest is 0. For B, the first 2 observations are under category B, so their value is 0, and the others are, their values are 1, and then the others are 0, and the last row we still see 1 because it belongs to category B, and the same for category C. Now, if you want to add a prefix to the column name, so we pass another argument, name prefix, get underline dummy, so we apply to the same data frame. This time we add prefix equal to key. So it's going to add key to all columns. Let me see. Prefix key. So we see this error because we are missing bracket here. So let's see. Now it adds key, underline, and then the column name. So that's how we pass prefix to each column. This method is very useful for handling categorical variables. And when we discuss scikit-learn library for machine learning algorithms, we are going to discuss some other transformation techniques like standardization variables or handling outliers. So stay tuned for more discussion on data transformation techniques and outlier identification. So with that, I finish our discussion about data preparation and manipulation when we are working with data frames.